First, let me show you. These are plastic European, they're called terminal strips, and you see you can take and cut them up into various sizes, 2, 3, 4, or just single, for doing rapid connections. And if you look at these really close, you're going to see that what they are is a block of metal inside that's threaded, and then 2 small little wipers that are pushed down to compress the wire when you connect. I just wanted you to understand how they're put together if you don't have any on your bench. And so what we want to do now is measure the capacity between 2 of these. Okay, so here's one here, and you can see there's no connection on this side. There's just that spacing in between. And I stuck on 2 wires so I can hook it to the capacity meter. So let me go ahead and zero the capacity meter first. Okay, this is a fairly inexpensive but highly accurate meter, and someone that's willing to spend around $100–110 you can get this meter. It does inductance and capacity and is quite accurate. Okay, let me hook this, go ahead and turn this meter on, and we'll let it calibrate. Okay, and now we'll go ahead and put it in capacity mode, and we have some residual capacity which we will zero out. Okay, now I'll go ahead and hook the terminal strip up. Now look, we'll call it, it's obvious I had to put the camera down. I've got the strip hooked up to it now. We're reading, and we'll call it 7.8, 7.7, and we're going to take 0.2 off of that. So 0.5, well, there's 8. Okay, let's call it 0.6 picofarad. So what I've got here is a SEC 18 standard L3. I'm running it off a 12-volt battery. And I have one of these terminal strips in between here. So we've got 0.6 picofarad coupling between the end of L3 and the input to the AV plug, running these 12 super bright LEDs which have a forward drop of about 3.2 volts. So multiply 12, 3.2. This clip lead here is merely a clip lead, just hanging off the bench here so that I can get, we'll call it an antenna or counterpoise, however you'd feel comfortable with it, and I'll hook that up. Now, in theory, we're going to say, wow, we got 0.6 picofarad here, we got 12 LEDs, and just this little clip lead hanging off the end of here that's doing absolutely nothing. Are we going to be able to develop enough voltage across the 0.6 picofarad to drive these LEDs? And of course the easiest way to find that out is for me to go ahead and connect the battery up, which I'll do right here. And lo and behold, we have enough signal coming off of the end of L3 at 3.6 picofarad to drive those 12. Now let me take off this little counterpoise, and we drop brightness considerably. So I just wanted to throw that out there. I had never, to be honest, in all these years, tried anything with such little capacity driving one of these boards, and I'm quite surprised by it. So I thought I'd throw the video up here.